Yes. Now, in this class, we are going to study what is the differences between compounds and as well as mixtures. And later we'll move into the next concept. So that is only called as, so we're having most of the substances in our surroundings. We're having what? What is the most of the substances in our surroundings? Mixtures. Yes or no? So these mixtures, actually what is a mixture? Anybody can tell? Mr. Gokul? Akilan?
Heterogeneous mixture.
No, what is a mixture I'm asking? Not heterogeneous mixture. Of course, heterogeneous mixtures. Mixtures also specification, heterogeneous mixture. What do you mean by mixture? Metakshri, Harish, what do you mean by mixture? Two or more pure substances. Two or more pure substances are combined together in maybe a uniform distribution or not uniform distribution. So that is what, based upon the distribution, we can say mixtures are two types. What is the mixtures are two types? Homogeneous mixtures and heterogeneous mixtures. Now, as we know, is it possible to use the mixtures same as we want? Suppose I want to use the salt, but salt is in dissolved state in ocean water. Is it possible to use the ocean water instead of, suppose I want to use salt for my curry? Instead of salt, can I use the ocean water? Can I use the ocean water? Is what I am asking. So I cannot use it. Is it yes or no? So that is why we have to separate the mixtures based upon our needy, and we have to use it our purpose. Is it yes or no? Yes, please. All of you. So that is why in this entire chapter, whatever we are going to study, everything is going to learn the next onwards, separation techniques of mixture. What is that? Separation techniques of what? Harish? Mixtures only. There is no compounds and there is no elements. So is it possible to separate the elements? That is what my first question. Is it possible to separate the elements? Everybody? No. Yes, please. No. So it is not possible to separate the elements. So which one is possible to separate? Only compounds and mixtures. So mixtures, which technique will use? Everybody. Mixtures, which technique will use? Physical methods or chemical methods? Physical methods. And compounds will use which method?
Chemical.
Okay. But in our class 9th, this chapter entirely will study which one? Compounds or mixtures? Separation techniques of what?
Mixtures.
Mixtures only. So that is why in exam also they will ask you, or else your textbook also will be having differences between mixtures and compounds. So let us study what is the example of what is the differences between these mixtures, and as well as same way how this compound is homogeneous, why this mixture is heterogeneous or homogeneous. We'll study that. So all of you please keep heading differences between mixtures and compounds. So what is our first concept of our today's class? Differences between mixtures and compounds. Is it okay, all of you? Everybody? So learn the definitions also, please kindly, and you have to make it. Anyhow, I'll try to finish the syllabus so that we can get practice also. Numericals also I'll teach. So differences between mixtures and compounds. Harini, where is Johan? Ask him to join fastly. So mixtures and compounds. So do all people know mixture and do all people know what is compound? Is there anyone who don't know what is mixture and what is compound? Metakshri? That's fine. Now, we can write around 5 differences between understanding mixtures and as well as compounds. So each one will explain what we already studied. Like last class, we studied the properties of compounds with the help of iron, compound of iron and sulfur. Yes or no? Nobody will answer. What I should do? Yes. Now, same way, before class, we studied properties of mixtures with the help of one mixture. What is that mixture? Anybody can say? Iron and sulfur mixture. Understanding? So properties of mixtures we studied, properties of compounds we studied. The same thing is called as differences between mixtures and compounds. Okay. So first one, what is a mixture? You can see here, a mixture can be separated into its constituents by what methods? Physical or chemical? Physical or chemical?
Physical.
Physical method. So what is the physical method? Example, filtration, evaporation, sublimation, distillation, solvents, magnets, etc. So solvents means, do you remember? Carbon disulfide we have used to dissolve sulfur and we separated iron and sulfur. Do you remember? Yes or no? Nobody will answer. Yes, that is what. So like that, we can separate the mixtures with the help of what methods? Physical or chemical?
Physical method.
Okay, Gokul, answer. Now, if it comes to the compounds, it cannot be separated by, cannot be, you can see here, cannot be separated by its individual constituents. By which method? By
Physical method.
processes. But it can be separated into constituents by only one processes. What is that process?
Chemical.
Chemical processes. So compounds will be separated by chemical process and mixtures will be separated by what process? Physical process. Next, mixture shows the properties of its constituents. Is it right or wrong? Answer to my question. Is it right or wrong? Now, for example, if I'll take iron and sulfur mixture. So what is the properties of iron and sulfur mixture? Everybody answer. Iron and sulfur mixture properties. It will show the properties of iron and it will show the properties of everybody. Sulfur. So that is what. So iron and sulfur only called as individual constituents. Yes or no, guys? Say yes or no, Johan and I also. Shall I need to beg you, people? So they are only called as what? Constituents. Understanding? So is it showing the properties or not? Is it showing the properties or not? Yes, please respond. Yes?
Yes, sir.
But as we know, if we'll take compound, iron and sulfur will react. We are going to get what? Iron sulfide. Now you tell me, iron sulfide will show the properties of iron and sulfur or entirely different properties? Entirely different properties. It will show the properties of iron and sulfur or entirely different properties. That is what I am asking. Please respond.
Different properties.
Different property.
Different properties. That is what the compounds. You can see the properties of a compound are entirely different from those of its constituents. So it will never show the properties of iron and sulfur. New properties will attain. New properties. Are you clear, everybody? Please respond. Yes?
Yes, sir.
That's all. So write it, everybody. So next, energy. Is it energy is given? Yeah, you can notice it here. So energy in the form of heat, you can see mixtures in the form of heat, light or etc. is usually neither given out or nor absorbed in the preparation of a mixture. Do you understand, all of you? To prepare a mixture, is it a physical process or chemical process? Physical or chemical?
Physical process.
Is it energy will given out? Is it energy will given out? No need of
No,
energy.
sir.
When
It's not here.
when the energy will absorb
No, sir.
or release, when the energy will absorb or release, only chemical reaction will take place. That is you have to remember. So in physical reaction, energy is neither given out or nor absorbed. But in chemical reaction, what is happening? Formation of compounds. Usually given out, energy is given out or absorbed during the preparation of a compound. So if you want to prepare the compound, either we have to supply the energy or might be energy is released. That is what we used to call as compound. But in physical process, no, neither given out nor absorbed. Is it okay, Mitakshri? Yes, ready?
Yes, sir.
Next. The composition of a mixture is variable. The constituents can be present in any proportion by mass. Is it right or wrong? For example, I will take 5 kg of iron and sulfur. Maybe 3 kg iron, 3 kg iron, 2 kg sulfur, or 4 kg iron, 2 kg sulfur. Is it right or wrong? Any proportion they may be present. Yes or no, Hari? Gokul?
Yes, sir.
Yes. But if it comes to the compounds, always what proportion? Always they have a fixed proportion by mass. Do you remember, all of you? So for example, if we'll take iron sulfide, what is the fixed proportion by mass? Fixed proportion by mass 56 into 32, as I told you in the last class. If we'll divide with the 8, so what is the ratio? Always by fixed proportion. What is that ratio, guys? 7:4.
Fixed.
So their mass is always in a fixed proportion in a what? In a compound, and they are having a definite formula also. Is it always iron sulfide formula FeS, or if you'll go to America, if you'll go to London, is the formula will change? That is what my question. Mr. Reddy?
No, sir.
No, always the formula is remains same. Understand, Harish? Johan and Harini only
sir.
will never respond. At least what you know, you cannot say. That is what. So always it is a fixed formula. At least in chart you can respond, Harini. So fixed proportion by mass and fixed definite formula. Next, is it mixture is having a same fixed melting point and boiling point? Everybody? Does not have
No,
fixed
sir.
melting point and boiling point. But if we'll take a compound always having a what? Fixed
Fixed
melting
melting point.
boiling point. Understand, everybody? Yes, please. So this is what is the difference between mixtures and what is that? Mixtures and
Compound.
compounds. Okay, so please make it. Understand, everyone?
Yes, sir.
Any doubt? Anybody can ask me. Understand, Reddy? So this is all about it. Now, as we know, most of our surroundings is what, guys? It is mixtures only.
Mixture.
Now, as we know, as we all people knows, always compound is a what? Homogeneous or heterogeneous? Always compound. Always compound is a homogeneous. Understanding, all of you? But mixture may be homogeneous, or what will become?
Sure.
Or
Heterogeneous.
heterogeneous. Now, so do you all people know why it is? Maybe it is always homogeneous because it will be having a definite formula and fixed proportion by mass. But if we take a mixtures, maybe some mixtures will show homogeneous. What is the example of homogeneous mixtures? What is the example of homogeneous mixtures? Solutions. And the example of heterogeneous mixture, already I taught you. Yes, please.
Suspension and colloids, sir.
Suspensions and colloids. Please note it down. That is what. So, if I have given some substance, will you all people can able to identify what is what? Either it is a compound or a element or a mixture or homogeneous mixture or heterogeneous mixture, like that. Will you able to identify?
Yes, sir.
Yes, that is what. Is it yes or no? I want the answer.
Yes, sir.
Yes. Now, if we take in our textbook, insert example only. So you might be noticing that. So let me see how many of you will fastly identify which is mixture, which is compound, and which is element. So I am keeping this. So let us see. Now, all of you can answer this question. Now, tell me which is element, which is compound, and which is mixture. Everyone, fast. Yes, please. Let me see who will answer. First, I'll identify. Classifying the following elements, compounds, and mixtures. First, sodium. Sodium, element. Silver, element. Tin, element. Silicon, element.
Element.
Silicon mixture. Who is that?
Element. Element.
That is what. Understanding? Next. That's all. Next. Compounds. Compounds, tell me. Compounds. Compound.
Calcium carbonate.
Sugar solution.
Next.
Calcium carbonate.
Yeah, calcium carbonate. Next. Methane. Next. Carbon dioxide. That's all. Is there any other thing? Soap also. Glycerin, it is soap. So these are what? Compounds. Understand how many compounds we have? 4
Four
compounds. And remaining things. What is the remaining things?
mixtures.
Soil, sugar solution. Next one, coal, air, and blood. All are called as, what is that called as?
Mixture.
Mixtures. So please write it. Everybody. I understand, Mitakshri? Your exercise second question it is, I think. So note it down, everyone. Any doubt, anybody can ask. Yes, please. All of you? Clear? Now.
Yes, sir.
So just now, as I taught you, mixtures can be 2 types. So as I told you, 2 types. What is that, guys? One is homogeneous. Another one is what?
Heterogeneous.
So homogeneous means it is called as, what is the example of homogeneous? Solutions. And heterogeneous what? Suspension. And as well as we can say what? Colloids. Yes or no? So now from here till here, is there anybody having any doubt? Ask me. So in our textbook NCERT book, till now whatever we studied, it will be present at the end of the chapter. That is what properties of elements, compounds and mixtures will be present at the last. Do you understand, everybody? Yes, please respond. So this chapter, second chapter will start with the mixtures. That is what 2 types of mixtures. One is homogeneous mixture. Another one is what? Everyone, heterogeneous mixtures. So homogeneous mixture means solutions. Heterogeneous mixture means suspensions and as well as what? Suspensions and as well as what? What?
Colloid.
Collide.
So we are going to start from the first case, that is what? Homogeneous mixture. So that is what? In the case of solutions. Let us see what is happening, why the solutions are called as homogeneous mixtures, and what will happen, everything we will study now. So right, the case of solutions. The case of solutions. What is the solutions? They are homogeneous or heterogeneous? What you know?
Homogeneous.
Homogeneous. What is the example of homogeneous solutions? Anybody can give? Yes, please.
Sugar solution, salt solution.
Take salt solution. Yes, only solution. Metals also, mixtures also there. Solid solutions.
Colloid, sir.
Alloys. Understanding? So that is what we can say brass, bronze. Understanding? So that is what. I already told you brass is made up of what and bronze is made up of what. Yes or no? Brass is made up of
Yes,
what?
sir.
Everybody? Brass is made up
Zinc
of
and copper.
zinc and copper, and brass is made up of zinc and tin. Understanding? Tin only symbol SN. Yes or no? So now observe very carefully.
Sir.
Yes, Hari.
Sir, bronze is copper and tin only, sir.
Copper and tin. Very good. Copper and tin, not zinc. Very good. Sorry that. So copper and tin. So if we'll take here, the solutions are always what kind of substances they are? Solutions always what kind of substances? Yes, please. They are the homogeneous substances. So that is what we all people knows. Now, these homogeneous substances, if we heat usually, understanding, then you can see are evolved or absorbed in the preparation of solution. All of you should remember, whenever you are preparing the homogeneous solutions, that is what solutions, then heat is evolved or absorbed in the preparation of a solution. What will happen, guys? Please respond. When we are preparing homogeneous substances, that is what solutions, what will happen? Heat, understanding, may evolve. What do you mean by evolved? Or what is that?
Released.
released, evolved or absorbed. Evolved or absorbed in the preparation. EVO LVED. EVOLVED. Evolved or absorbed in the preparation of solution. In the preparation of solution. So when we are preparing homogeneous mixture, might be heat is evolved or heat is absorbed. Is it okay, ready? Yes, please.
Yes, sir.
Respond. That is what you have to remember. So now we'll take the examples also. If we'll take, so the solution is considered as a mixture only because of two reasons. Why we are considering solution is a mixture, solution is a homogeneous mixture? Anybody can tell me? Of course, even though the heat is releasing, basically differences you studied is neither heat is released or neither heat nor heat is absorbed. Yes or no, Metakshri? Yes.
Yes, sir.
So mixtures, is it possible to release the energy? Neither nor. Yes or no? So it is not possible. But in case of homogeneous solutions, it is possible. But still we used to consider as homogeneous solution is a mixture. Why? That is what my answer. That is what my question. Let me see who will answer. Even though the heat is absorbed or evolved during formation of solution, why the solution is considered as a mixture? That is what my question. Mr. Hari, Mr. Akilan, Johan, anybody can answer. Of course, this is one of the typical question which you people will never see anywhere. Let me see who will answer. Metakshi? Yes, please. Answer to my question. Anybody ready? What is the question I asked? Usually the mixtures heat neither nor released or absorbed. Is it right or wrong? You studied or not properties? Yes or no? Differences between mixtures and compounds. Yes. So if the solution is a mixture, then still when the solution is forming, either heat is absorbed or heat is evolved or released. So I want to know why the solution is considered as a mixture. What is the properties? Try to answer, guys. You all people knows. First thing, is it necessary to use the chemical process to separate the solution? That is what my first question. Let me see who will answer. Is it necessary to use the chemical process to separate the solution?
No, sir.
No.
No, sir.
Can be separated by which methods?
Physical
Methods.
methods.
Next, is it will shows the properties of entirely different or same constituent properties?
Same constituent. Same constituent.
Next, is it having a variable composition or uniform composition?
Uniform.
Uniform. Formula. Uniform or different?
Different, sir.
Different composition, variable composition. Next, is it having a fixed melting point and boiling point?
No, sir.
No.
No.
So that is why it is called as, what is that called as? Solution is a mixture, not a compound. Understand everybody? So write it. A solution is considered a mixture. A solution considered as a mixture because of what is the reason? Because what is the reason, guys? First one, everybody, it can be separated into its components by physical methods. It can be separated. Now getting salt from seawater, how? Which method? Which physical method?
Evaporation.
That is what. It can be separated by physical methods. Next, what is the second point? Ready? Akilan. It shows the properties of its constituents. Shows the properties of its constituents. Is it new properties or same properties of constituents?
Same property, sir.
Same properties. Next, variable composition. Next, last one, melting point and boiling point. So does not have a fixed boiling point. Does not have a fixed boiling point. So that is why the solution is considered as a mixture or compound. What it is? Mixture or compound? Mixture. Are you clear, everybody? Yes, please.
Yes.
Yes, that's all. So write it. Are you clear, Akilan?
Yes, sir.
You go, Gokul, Johan,
Yes, sir.
Harini. I want your notes. So today evening, just bring your notes. Till now, whatever you have written, I want to see. Understand, Harini and Johan? Both of you. I'll see that. Okay, write it. So till here, any doubt, anybody can ask me. Are you clear, guys? Yes, Mitakshri, you?
Yes, sir. Yes, sir.
So if we take example, what is the example of solution? Best example, salt solution. What is the example of solution? First, best example?
Salt solution.
Salt solution.
Understand? So salt solution we can. So that is what it is. So now, what is the physical method we can use it into salt and water at a time? Not only salt. I want to get water and salt. So example, let me see who will say. Example, salt solution. Now I want to get salt plus water both. So what method I have to use? Don't say me evaporation. Other than evaporation, keep on saying me, I will say which is correct. Yes, please. Mitakshri, let me see. So which physical process we will use to get both salt plus water? I want to get it. Let me see who will answer. You might be
Separating funnel.
No, separating funnel. How, Mr.
Distillation.
Very good. Separating funnel, we will use it for only immiscible liquids. Understand, Mr. Rama? So,
Yes, sir.
use
The
it-
fractional distillation and
Yes.
distillation.
we will use a method called as distillation. Do you understand it? So why can't we use evaporation, Mr. Reddy and Mr. Harish here or Johan?
Because
water
we can't get water.
Yes, we cannot get the water back, but if we'll use distillation technique, we can obtain what? Both salt and as well as what? What?
Water.
That is the first thing. Next, salt solution will source. Both properties are same properties. That is the second thing. Yes. Nobody will answer. Is it will source both water properties and salt properties, or it will source entirely different properties?
The same properties.
Same properties. That is what salt solution shows the properties of salt and water. Shows properties of salt and water. Do you understand, everyone? Mitakshri? Now, third property. What is the third property? Variable composition. Is it yes or no? Yes, please.
Yes.
Variable composition. Is it having a definite formula? Not having a definite formula. Understanding? Not having a definite formula. So, for example, Reddy will take 100 ml of water. How much ml? 100 ml of water. 10 grams of sodium chloride. That is what salt. Are you clear? Now, Omar will take same 100 ml of water and 20 grams of salt. Now, is it composition is same? Is it composition is same? I'm asking. So, composition
No,
of
sir.
salt solution, composition of salt solution, composition of salt solution is variable. Why it is variable? Because, understand, different amount of salt can be dissolved in the same amount of water, so that different composition. Understand, Hari, now why what I said? Composition
Yes,
of
sir.
salt solution is variable. Why? See here, water amount is same, but amount of salt is varying or not? Everybody,
Yes, sir.
yes or no? So that is the reason I have told you this. Next, last property. Is it having same or different boiling point? Does not have a fixed boiling point. Does not have
Yes, sir.
fixed boiling point. So why it's not having a fixed boiling point? Anybody? Now, for example, whatever the solution prepared by methoxy, 100 ml of water and 10 grams of salt. Now, is it will be having a is it will be having some boiling point or not? Yes, please. Yes, everybody. Is it will be having some boiling point or not? Now, same 100 ml of water, Harini prepared 50 grams of salt. Now, is it both the solutions will burn with the same boiling point or different boiling point? Yes, please. Different boiling point. Why? Composition is varies. So if the composition is varies, boiling point will varies or not, Hari? Yes,
Yes, sir.
that's all. So that is what. So here BP is different and here BP is different. Right, that's all. Are you clear, everyone? Yes, Mitakshri? Harini?
Yes, sir.
That is what. So please write it. So that is what example and the properties of a solution we studied without any. I think hope all are understand. Is there any doubt? Let me take. Let me ask. Hello. Hope everybody clear. Yes, please.
Yes, sir.
Okay. So this is what about it. So that is why you can see when I have given, for example, I have given you two liquids. Then how you can get? Anybody can tell? If I give you two liquids, pure compounds and other solution. So both are two liquids, one upper compound and other a solution. How you can separate it? How you can find it which is a compound, which is a solution? Mr. Hari, Mr. Reddy, I want.
Sir.
Yes,
So what is the question?
I have given you now one solution. You understand? I have given you two liquids. Mitakshri, everybody understand? I have given you two liquids. Ready? Akilan, Gokul, everyone. So one is solution. You don't know which is solution, which is mixture. Okay, I have given you two solutions. One is mixture and another one is solution. So now both are liquids only. Understand, Ready? Both are
Yes, sir.
liquids only. Now, how will you identify which is solution, which is mixture? That is what I want. Anybody?
So during the like,
Different prop-
during preparation, if heat is evolved or heat is observed,
But solution,
it is solution, sir. If
but solution also heat is absorbed or heat is released. Am I told you or not, Mitakshri? Harini?
yes, sir, but said that not no, sir.
Yes, Harish, but it's not the correct explanation. Harish, think a little bit more. You might be. You might be getting answer. Yes, please. Mitakshri,
Comparing the properties, sir.
how ready? How you'll compare? Both I have given a transparent liquid. How you'll compare?
So
You
by
should,
Tyndall effect.
you should not touch them. You should not go for any analysis. Yes, please. Now, how you'll? Anybody? Anybody can answer.
Tyndall effect.
Tyndall effect? No. Tyndall effect is a colloidal substance, not the solution. Solutions will never show Tyndall effect. Understand, ready?
Yes, sir.
Next, any other idea? See, you are thinking more behind unnecessary things. We are forgetting the main thing. So now, suppose I will heat the solution, or if I will boil the solution, or if I will evaporate the solution, at last down it will leave you something. Is it yes or no? Yes or no?
Yes, sir.
It is called as what? Residue. What is to call? What is to call?
Residue.
Residue. So if I heat the salt solution, what is left in the beaker? Or else if I evaporate the salt solution, what is left in the field? Everybody,
Salt.
salt. But is it possible to left something in the case of compounds without Sri?
No, sir.
No, that's all. So then how you will identify? That is the first thing. So we have to find out of which one is compound or which one is solution. So what we have to do means just evaporate them separately. How we have to do? Evaporation. Do you understand, everyone? So what we have to do, guys? Respond. Evaporate. Understanding, everybody? So if you evaporate, that's all. So what will happen, everybody? Evaporate them separately. So if it is a mixture, what will happen, Hari? Separately. If it is a mixture, what will happen, Reddy? Please respond, Reddy. Gokul. Yes, if it is a mixture, what will happen? That is not my question.
Sir, it won't leave any residue.
No, mixture will leave the residue, but compound won't leave the residue. Understand, Mitakshi? Because we are doing evaporation. Evaporation means physical process or chemical process.
Physical process. Sir, evaporation is a surface phenomenon.
Yes, surface phenomena. I know that. Is it a physical process or chemical process? I am asking.
Physical process.
Now, if I evaporate both liquids, so now which liquid will leave the residue? Which liquid will never leave any residue? That is what my question. Anybody? Yes, please. So mixtures always will leave the residue by evaporation. Yes or no, guys? Salt solution. By evaporating water, what will left at the bottom? Salt solution. What will left? That is what my question. Salt solution, by evaporating water, what it will leave in the container? Yes, please answer. Salt. But is it possible to see anything which is left in the beaker or bowl after evaporating the compound? That is what my question. Is it possible or not? Everybody. Is it possible in the case of compound? Mitakshi? No. Okay, right. A liquid which evaporates completely, a liquid